Welcome back to the deep dive. Today we are taking a long, hard look at the single greatest mass murderer in human history. And I want you to just discard all your assumptions right now because we're not talking about a political leader, a weapon, or even a global conflict.
We're talking about the mosquito.
Hmm.
And the scale of her historical impact, I mean, when you truly quantify it, it's genuinely staggering. When researchers look at statistical extrapolation, they're suggesting that mosquito-inflicted deaths, the cumulative toll over 200,000 years of human existence, are approaching half of all humans that have ever lived.
Just stop and think about that figure for a moment. That is nearly half of all people who have ever been born. The total count is somewhere around 108 billion humans ever.
Which means the mosquito is responsible for taking out an estimated 52 billion of us. It's the ultimate chilling biological check on our population.
It is, but there's a really essential distinction here, isn't there? One that historians, well, they frequently seem to overlook.
Right. The mosquito itself, which is, roughly the size and weight of a grapeseed, doesn't kill anyone directly. Its purpose is just to feed. It's the toxic and highly evolved diseases she transmits, the parasites, the viruses that cause all the death and desolation. The mosquito is just the vehicle.
Exactly. She is the sidelined spectator, the unseen architect that historians have consistently. Well, they've defamed her by focusing only on human agency. We attribute the fates of empires, the outcomes of wars. We attribute it all to leaders, politics, economics.
But the biting truth, if you'll pardon the pun, is that the mosquito, acting as our deadliest predator, our most influential general, really drove the events of human history to create the reality we live in right now.
So our mission today is to unpack that evidence, to show this indelible impact across millennia.
We're going to look at her role in driving our own evolution, orchestrating the rise and fall of civilizations, entire economic systems, and even becoming a central factor in modern biological warfare.
And when we talk about this dominion of death, we're really talking about two main perpetrators, right? The leading ladies who do most of the killing.
That's right. First, you have the gene Cynophales. She is the sole vector of the 5 human types of malaria plasmodium.
Malaria, the ancient enemy, the one responsible for the vast majority of those 52 billion deaths.
And then you have the newer viral threat,
Which would be Aedes.
the genus Aedes,
Yeah.
a highly effective modern killer. She transmits a whole catalog of viruses: yellow fever, dengue, chikungunya, West Nile, Zika.
The malaria and yellow fever, those are the big two.
They've been the prevailing agents of death and historical change. They're the primary antagonists in this protracted, unending war between us and the mosquito.
Okay, so let's unpack this biological blueprint. Let's start with deep history. When did this war actually begin? Because we're talking about a history that predates us by hundreds of millions of years.
Oh, way before us. Long before mammals even showed up. Insects first appeared some 350 million years ago, which makes them the ultimate survivors. And as soon as they evolved the ability to bite, they attracted this toxic army of diseases, parasites, viruses, bacteria. The sources call it an unprecedented lethal alliance.
And we have actual fossil evidence of this.
We do. We have fossils of Jurassic mosquitoes and sandflies that were already armed with biological weapons.
And there's that fascinating theory from paleobiologists that links these ancient insects to one of history's greatest extinction events.
The demise of the dinosaurs.
Right.
That's where it gets really interesting. The theory is that, the asteroid impact was the final nail in the coffin, but the slow decline was already happening. And these insect-borne infections, along with other parasites, became more than the dinosaurs' gargantuan immune systems could handle, especially if their habitats were already stressed.
So the sheer number and variety of biting insects would have just given microorganisms an almost limitless chance to spread.
Precisely. Biting insects, armed with their deadly microbiological weapons, were essentially the top predators in the food chain millions of years ago, just as they are to us today.
So while the great dinosaurs perished, the bugs that helped kill them just kept on going.
They endured. They endured to inject death and disease into humanity throughout our entire history. They are, in every sense, the ultimate survivors, biological opportunists.
The ultimate survivor that only needs one thing from us, our blood. But only from the females, right? And only for reproduction.
And the sheer sophistication of this tiny killer's feeding ritual is just astonishing.
It's not just a simple bite.
Not at all. It's an intricate, almost surgical process. It's driven solely by her need to mature her eggs. She'll usually target an exposed, relatively safe area, often close to the ground.
Like your ankle.
Exactly, the ankle. First, she conducts this tender, probing 10-second reconnaissance, looking for a specific thermal signature for chemical attractants. She's zeroing in on a prime blood vessel.
And once she's found her target, how does she actually get in? I heard it's more complex than a simple injection.
It is. It involves 6 sophisticated, specialized needles, all bundled together inside a protective sheath called the labium.
6 needles.
6. First, 2 serrated mandible cutting blades literally saw into your skin to create a passage. Then 2 other retractors hold that passage open. Then the true hypodermic syringe, the proboscis, emerges and starts to suck about 3 to 5 milligrams of your blood.
And she doesn't actually keep all that liquid, does she? She's after the protein.
That's the clever evolutionary part. Blood is mostly water, so she needs to condense it fast to get the protein for eggs. So she immediately excretes the water she doesn't need, condensing that 20% protein content while she's still feeding.
I think I've seen that little droplet of clear liquid right before she flies away.
That's it. Which brings us to the final, critical piece of the puzzle. The anticoagulant.
Right, the thing that makes you itch.
That's her evolutionary Hail Mary. The 6th needle pumps in saliva that contains a cocktail of chemicals, most importantly an anticoagulant. It prevents your blood from clotting at the puncture site.
So she gets a quick, uninterrupted meal.
And by speeding up her feeding time, she lessens the chance that you feel her and splatter across your ankle. That saliva, with the anticoagulant and other proteins, is what causes the allergic reaction, the itchy bump. That's her parting gift after she's potentially delivered a lethal payload.
And in stark contrast to these female assassins, you've got the male mosquitoes.
Whose world revolves entirely around nectar and sex. They're basically harmless to us.
So their main concern is finding a mate. And that's where the swarm comes in.
Yes, the mosquito swarm, you've probably seen it. Males assemble over a prominent, dark, fixed feature, a chimney, an antenna, a bush, or a person.
So if you've ever been followed by that persistent cloud of bugs droning over your head.
You have been unintentionally honored as a swarm marker. Females then fly into these hordes to find a mate.
And once she's mated, that's it.
That's it. She stores a sperm and only needs that one dose to produce numerous batches of eggs throughout her short life. And for every single batch, she needs your blood.
This intense, perpetual pressure from the female mosquito forced a dramatic and, well, a really specific evolutionary response in humans, especially with malaria.
This is one of the most powerful examples of an environmental pressure just completely altering our genetic blueprint. The first appearance of this sickle cell trait was a direct result of expanding agriculture.
About 8,000 years ago, right? When farmers started encroaching on undisturbed mosquito habitats.
Exactly. We're talking about pioneering Bantu farmers in West Central Africa along the Niger River Delta. They started cultivating yams and plantains, which meant they had to clear forests.
And that created large, sunlit pools of stagnant water.
The perfect breeding ground for Anopheles mosquitoes. This intensification unleashed vampiric falciparum malaria, the deadliest type on its new, concentrated human host.
And our body's response to this sudden, massive threat was, what, a kind of desperate improvisation?
It was what the sources call a hasty and imperfect evolutionary counteroffensive. The pressure was so severe that within only 700 years, which is a blink of an eye, evolutionarily speaking, a random mutation caused the hemoglobin in our red blood cells to become stiff and sickle-shaped.
And the genius of that defense is that the malaria parasite can't latch on to that misshapen cell.
It can't. It effectively stops the parasite's replication cycle dead in its tracks.
But at a tremendous cost to the host.
A huge cost.
Yeah.
What this shows you is the sheer scale of the threat. The mortality rate was so high that this gene, which is potentially fatal if you inherit 2 copies of it, was kept in the gene pool because carrying just 1 copy of the sickle cell trait gave you enough protection against malaria to survive and reproduce.
So it was arguably the single biggest evolutionary pressure on our species in the last 10,000 years.
Without a doubt.
And we still see the modern relevance of this ancient defense in some really surprising places, like the NFL.
It's a powerful, tangible connection to our deep history. Take the NFL safety Ryan Clark Jr. back in 2007. Here's a finely tuned professional athlete. But when his team played in Denver's Mile High Stadium,
Over 5,000 feet above sea level.
the reduced oxygen in the air triggered symptoms related to the sickle cell trait he carried. It resulted in severe pain and organ damage that nearly killed him.
And this wasn't just a one-off incident, was it? It highlighted a much bigger vulnerability.
It did. The sources note that 1 in 12, or about 4.2 million, African Americans currently have the sickle cell trait. And 70% of NFL players overall are potential carriers.
So Clark's experience actually changed policy.
It did. It forced the league to finally study the effects of altitude and sickle cell seriously. Now, players with the trait sometimes have to sit out games in high-altitude stadiums. It's a living legacy of their ancestors' fierce 8,000-year-old fight for survival.
And sickle cell is just one piece of the human defense arsenal. We also have other remarkable genetic shields like Duffy negativity.
Duffy negativity was, chronologically, our first genetic response to malaria, showing up about 97,000 years ago. It's a defense against vivax malaria, which is very widespread, though usually less lethal than falciparum.
And what's the actual mechanism there? How does lacking a blood protein save you?
So the vivax parasite uses a specific chemical key, which is the Duffy antigen receptor on the surface of your red blood cell. It's the gateway the parasite has to use to get inside the cell and replicate.
And the mutation just gets rid of that gateway.
It closes the portal. The genetic mutation means your red blood cells just don't produce this antigen. No antigen, no entry for the parasite.
And the prevalence of this trait is pretty high in some populations.
It's astonishingly high. Right now, 97% of West and Central Africans carry this mutation, making them naturally impervious to vivax infection. And that becomes incredibly important later when we talk about slavery and colonization in the Americas.
The third defense we should cover is G6-PDD, or as it's more commonly known, favism.
G6-PDD. It stands for glucose-6-phosphate dehydrogenase deficiency. It offers partial immunity by disrupting the normal metabolism of the red blood cell, robbing it of an enzyme that protects it from oxidant stress.
So it creates a hostile environment for the parasite.
Exactly. It inhibits its ability to reproduce. The drawback, though, is that carriers are fine until they're exposed to specific triggers.
And those triggers are what make this so interesting. They include anti-malarial drugs like quinine and fava beans.
Which is how it got the name favism. Eating fava beans can trigger a hemolytic crisis where your red blood cells break down. This trait is mostly found in Mediterranean, Middle Eastern, and North African populations.
And you mentioned there's even a cinematic connection.
Right, in MASH. Fans might remember Corporal Klinger developing a serious illness after being prescribed primaquine. The writers were being subtly accurate, given Klinger's implied Mediterranean ancestry. It wasn't just a plot device, it was a real medical risk.
Which perfectly leads into seasoning, the final, brutal, and non-genetic resistance, which is so critical for understanding colonial history.
Seasoning is acquired immunity, not inherited. It's the result of chronic infection building up a marginal tolerance over time.
So in places with a lot of malaria, children and adults who survive repeated infections.
Maybe once, twice, 3 times a year. They start to develop milder symptoms. They're still carriers, but the infections don't kill them anymore. It nullifies the risk of death.
So it's not true immunity, it's more like a biological truce. The body is just in a constant low-grade war.
That's a perfect way to put it. They are perpetually sick, but functionally alive. It's not pleasant, but it's effective. And this acquired immunity became a crucial factor in the wars of colonization and liberation in the Americas, giving African and local populations a huge physiological advantage over newly arrived Europeans.
Before we get to the wars, let's touch on nature's pharmacy. Humans weren't just evolving biologically, we were also, figuring things out through trial and error.
That knowledge, often born of necessity, survived the jump from ape to human. We have sources detailing how chimpanzees still chew the leaves of the Mululuza shrub to get relief from malaria symptoms. It's a remedy passed down through generations of primates.
And that shrub is related to one of the first known commercial pesticides from ancient China.
Yes, Mululuza is in the same family as chrysanthemums, or pyrethrum. We know the dried flowers were used in China around 1000 BCE before spreading to the Middle East as Persian powder. It attacks the nervous system of insects, including the mosquito.
The sources even suggest the mosquito might have indirectly trained our taste buds.
It's an intriguing idea. Things like cloves, nutmeg, cinnamon, basil, onions, they all have properties that seem to soften malaria symptoms. It might explain why people in malarious regions added these nutritionally hollow but flavorful ingredients to their diets for millennia. They weren't just seeking flavor, they were seeking relief.
And that brings us back to that critical, forgotten discovery from ancient China.
Absolutely. Hidden inside a 2,200-year-old Chinese medical text was a description of the fever-curing benefits of drinking bitter tea made from Artemisia annua, the sweet wormwood plant.
The chemical compound being artemisinin.
A powerful malaria assassin. A fact that was completely lost to Western medicine and mostly forgotten by the Chinese themselves until the modern era. The fact that the solution was literally written down 2 millennia ago is just a profound historical footnote.
Okay, now we get to the core of the mosquito's role as the unseen architect of history, General Anopheles and the fall of empires. And to understand her power, we need to start with how ancient cultures even thought about disease.
Well, without a microscope, they couldn't see the parasite, so they personified the disease. You have Indian medical texts from 1500 BCE personifying malaria as the fiery fever demon Takman, who comes from lightning during the rainy season.
So an early, if mythical, link between water and fever.
Right, and the Chinese certainly recognized the brutal reality of it. We have an account of an enraged emperor beheading his emissary for refusing to become governor of a malaria southern province.
Because he knew it was a death sentence.
Exactly. The career risks were existential. And Sima Qian's historical record from 94 BCE confirms that south of the Yangtze, where the land was low and humid, adult men died young, much earlier than in the north.
And that inequality of disease just stunted their economic development for centuries.
It absolutely plagued it. It robbed the region of its productive male labor force.
All right, let's move to the Greek crucible. Alexander the Great's meteoric rise was only possible because preceding conflicts had left the world in, financial decay and political disarray.
The Greco-Persian War set the stage, but the mosquito played a crucial role in thinning the ranks of the Persians. Take the Battle of Marathon in 490 BCE. Darius I unleashes a 26,000-strong amphibious landing.
And crucially, the Athenian hoplites confined the Persians to low-lying, marshy encampments right by the coast.
The perfect mosquito habitat. Within a single week, before the decisive Athenian charge even happened, the sources say the Persian force was already severely thinned by disease. The sickness created a decisive advantage for the Athenians.
So the mosquito was the advance guard, weakening them before the fight even began.
Absolutely. And this theme continues spectacularly with the plague of Athens.
During the Peloponnesian War.
430 BCE. Athens was overflowing with over 200,000 refugees crammed within the city walls to protect them from the Spartans. The density, the hygiene issues, the shortages, it was a guaranteed catastrophic epidemiological failure.
And historians still argue over what exactly it was.
They do. The historian Thucydides, a survivor himself, left this exhaustive eyewitness account, but the cause is still debated. Top contenders are typhus, malaria, or a viral hemorrhagic fever like yellow fever. But whatever it was, it ripped Athenian society apart, killed their leader Pericles, and ensured they lost the war.
The rise of Rome was also initially helped by the mosquito crippling Rome's enemies.
The Carthaginians, Rome's main rivals, suffered repeated mosquito-borne disasters. In 396 BCE, they launched a siege of Syracuse, digging in along the swamps around the city. Their force was racked by malaria, and they perished to a man, forcing them to lift the siege.
But the mosquito's greatest service to Rome involved Hannibal, after his victory at Cannae.
Right, 216 BCE. Hannibal should have marched on Rome. He had just annihilated their legions, but his forces were diverted, partly because of the pervasive malarial marshlands of Italy. The soldiers were falling sick. They couldn't maintain their campaign's ferocity.
The sources explicitly state that the treacherous fleshpots of Campania had diverted Hannibal from Rome.
And therefore from victory. The mosquito helped safeguard Rome, which was a critical pivot point for Rome's command of the Mediterranean.
But the mosquito is a mercenary, loyal only to biology, and she soon turned on Rome, ushering in the empire's decline.
As Roman legions and merchants swarmed across Europe, so did malaria, extending its grip as far north as Denmark and Scotland. And ironically, Roman success, their advanced infrastructure, contributed to their own demise.
The gardens, the baths, the aqueducts.
All of it. Neglected ponds, cisterns. They created these vast protected havens for mosquito propagation. Italy became known to invaders by the name Roman fever.
And this wasn't just an inconvenience. Malaria became a systemic, chronic problem that directly catalyzed the empire's decline.
The mechanism was insidious. It created this merry-go-round of labor-draining illness. Chronic infections meant farmers couldn't work their fields. That led to food shortages, which weakened the population, which lowered tax revenue.
At the same time, life expectancy was, 20 to 25 years? And infant survival was terrible.
Less than half of infants survive childhood. So you have a constant manpower shortage for both agriculture and, crucially, for the legions needed to protect the borders. The mosquito was working from the inside out to ensure the empire's failure.
And when the empire finally imploded, General Anopheles stepped in again to humiliate invaders who thought Rome was an easy target.
She provided Rome with this unexpected final line of biological defense. The Visigoths, led by King Alaric, sacked Rome in 410 CE. But his forces were exhausted and ruined by malaria soon after, having encamped in the marshy Tiber Valley.
Alaric himself died from it.
Succumbed to the disease in the fall of 410. And then came the Huns, led by Attila.
He halted his campaign in 452 CE, keenly aware of what happened to Alaric just 40 years earlier.
His cavalry troops were emaciated, weakened, after pasturing their horses in the watery lowlands where mosquitoes breed. The source suggests his famous meeting with Pope Leo. I was just a ruse to save face and provide an excuse to abort his mission. Malaria rendered the Hun military impotent.
Let's jump forward 6 centuries to the Crusades, the first large-scale European attempts at permanent colonization outside the continent.
The Crusades were religious, sure, but they quickly became these hugely lucrative commercial enterprises. They established small states like the Port of Acre. But in the Third Crusade, Richard the Lionheart and his European cohorts marched right into a maelstrom of death they were biologically unprepared for.
The Siege of Acre was a death trap.
It was. The Crusaders were confined, and Saladin shrewdly surrounded them, allowing the mosquito ample opportunity to feed on the trapped, unseasoned Europeans. Malaria killed roughly 35% of them. Richard himself contracted what they called Arnoldia, or malaria. His strength was sapped. His forces were rendered impotent.
And Richard's illness and forced retreat had massive long-term implications for England itself.
It created this bizarre causal chain that leads directly to the Magna Carta. Richard's forces, sick with malaria, had to quit the Levant in 1192. On his way back, he was captured. To muster the huge ransom, his mother massively increased taxes across England.
Which people resented.
Deeply. King John, his successor, continued the practice. This resentment ignited the baronial revolt that led directly to the Magna Carta in 1215, constraining the power of the king. The mosquito ensured the first European imperial ventures failed, and that failure ultimately led to the framework for modern English liberties.
Finally, let's talk about the Mongol halt. Genghis Khan binds the East and West. So why did the world's most successful conqueror suddenly turn back from Western Europe?
Their expansion was actually helped early on by a mini ice age. But that climate change became a double-edged sword. As their armies marched into Western Europe, the high rainfall and humidity created the perfect storm to stop them.
High rainfall means no grazing for their horses.
That was the logistical failure. Their power was based on swift, horse-powered armies. Soggy ground crippled their mobility. Plus, the high humidity caused the specialized glue in their compound bows, their main weapon, to fail.
They literally couldn't shoot straight.
And compounding all of this was a bursting population of mosquitoes.
Attacking their virgin veins.
Exactly. The Mongol armies had no genetic or acquired seasoning against European strains of Anopheles. The combination of soggy ground, broken bows, and rampant fever forced them to admit defeat and withdraw from Western Europe.
And we see this with Kublai Khan's campaigns in the south, too.
Right. Kublai Khan, Genghis's grandson, disregarded the usual Mongol tactic of withdrawing forces to the non-malarial north during the summer. As a result, malaria just ravaged his armies in southern China and Vietnam, inflicting huge losses and forcing them to abandon the campaign entirely by 1288.
Part 3. We're crossing the Atlantic to the making of the Americas, where the mosquito acts as an accidental conqueror, European ships sail over, and Anopheles and ADs are stowaways.
And the sheer magnitude of the catastrophe is hard to grasp. Along with bacteria like smallpox, the mosquito was culpable of genocidal extermination on a scale never seen before. We're talking an estimated 95 million indigenous deaths, a 95% decline in the centuries after Columbus. The sources call it the largest single population catastrophe in recorded human history.
And this mass die-off created a labor crisis that drove the transatlantic slave trade.
Precisely. As indigenous labor was extinguished, the Taino and Hispaniola were basically extinct. By 1535, African slaves became the mandatory replacement. And the reason they were indispensable to the plantation economy, producing massive wealth from sugar and coffee, was entirely biological.
The plantation owners didn't know the genetic sickle cell, Duffy negativity, but they saw the effect in purely economic terms.
They could measure it in survivability and profit. African slaves did not die at the same catastrophic rate as unseasoned Europeans or the indigenous populations. Their inherited shields and, crucially, their prior seasoning to yellow fever and malaria meant they could survive in the deadly climates of the Caribbean and South America.
In other words, the mosquito made African slavery both profitable and mandatory for colonial enterprises in the tropics.
It was an economic reality driven by biology. If an owner bought an unseasoned European laborer, that worker would probably die within a year. A seasoned African slave was a viable long-term investment. The mosquito decided the demographics and economics of the New World.
The same mosquito, though, provided an African firewall against European intrusion into the continent's interior.
For almost 300 years, that firewall turned sub-Saharan Africa into the infamous white man's grave. European expeditions consistently suffered 80 to 90% death rates. Even the coastal slave trading centers were boneyards, with annual European mortality around 50%. European colonization was limited to the coasts till the rise of quinine.
Let's look at three specific monumental failed colonial ventures decided by the mosquito. First, Sir Francis Drake's Caribbean raids.
Drake's fleet, the spearhead of English imperial ambition, was already infected with falciparum malaria from West Africa. The entire campaign was plagued by sickness. He lost 950 of his 2,300 men to extreme hot burning and continual agues. The mosquito captained his fruitless campaign.
And his final fate.
In January 1596, Drake himself died from a lethal mix of malaria and dysentery in what is now called Mosquito Gulf off Panama. His failure forced English imperialized north towards the less disease-ridden coasts of North America, shifting the entire trajectory of English colonization.
Next, the catastrophic Darien disaster, which is maybe the best example of the mosquito liquidating a nation's treasury.
This is a geopolitical tragedy. A Scottish nationalist, William Paterson, planned to carve a trade route through Panama at Darien. Scotland, desperate for economic relief, invested an astonishing amount, between 25 and 50% of the country's total liquid capital.
The Spanish had already lost 40,000 men trying to hold that area. The Scots had no chance.
They feared far worse. The mosquito made a death row last meal of 80% of the 2,500 settlers within months. All the money was lost. The economic collapse of the Scottish treasury caused immediate bankruptcy and ultimately forced the deeply unpopular unification of Scotland with England in 1707. The mosquito literally ate away the sovereignty of an independent European nation.
And finally, French Guiana in 1764.
France needed a massive colonial bastion after losing Canada. They tried to build a huge colony at Kourou, but within a year, yellow fever, dengue, and malaria, a three-headed Cerberus epidemic, killed 11,000 settlers, 90% of them. This disaster cemented the mosquito's role in deterring European power in the tropics.
And yet, the mosquito proved to be a mercenary ally for the forces of independence. Let's start with the Haitian Revolution in 1791.
Haiti, or Saint-Domingue, was the richest colony in the world, fueled by 500,000 African slaves, 90% of whom were seasoned to local diseases. When Napoleon tried to quell the revolt, he sent 30,000 unseasoned French troops.
The survival rates are just horrifying.
The French troops died at a rate of 90 to 95%, mostly from yellow fever. General Leclerc, Napoleon's brother-in-law, wrote these heartbreaking letters home about the fever wiping out his forces. This disaster forced Napoleon to abandon his North American dream and sell the Louisiana Territory to Thomas Jefferson in 1803.
So the mosquito was the real estate agent for the biggest land deal in American history.
Doubling the size of the new nation. A similar, if less dramatic, advantage played out in the American Revolution.
Washington's Continental Army was more seasoned.
Exactly. They had marginal tolerances to the endemic diseases. The British, desperate for a win, shifted their strategy to the malarious southern colonies in 1780.
And this exposed their vulnerability.
Because their forces were up to 70% unseasoned troops, mostly from Scotland and northern England. The relentless fever of the Carolina lowlands decimated their combat effectiveness, which aided the American victory at Yorktown in 1781.
And there's that great cultural footnote about the switch from tea to coffee.
Right. Colonists suspected coffee-drinking French colonists suffered less from agues and fevers than the tea-drinking English. Coffee was peddled as a wonder drug. This, plus the push after the Boston Tea Party, may have helped inspire a nation of tea drinkers to switch permanently to coffee. Malaria might explain how the nation of the Boston Tea Party became today's land of the latte.
Finally, Manifest Destiny and the Mexican-American War. This was different because American military planners finally learned to strategize around the mosquito.
Yes, General Winfield Scott secured massive territorial gains: California, Nevada, Utah. This was possible because Scott achieved tactical awareness of the vector even before it was scientifically confirmed.
So he just avoided the mosquitoes.
He consciously avoided the teeming lowlands, especially the coast, and refused to campaign during the summer months, peak season for yellow fever. Scott's awareness secured victory and showed a profound inflection point. Once humans acknowledged the power of the unseen enemy, they could finally adapt.
Okay, part 4. We're unmasking the predator and moving into the modern war, starting with early, chilling attempts at premeditated biological warfare.
The Civil War gives us a chilling example with Dr. Luke Blackburn, a Confederate zealot. He was determined to unleash yellow fever on the north.
And his method was unconventional.
It was. In 1864, he got soiled clothing and bedding from yellow fever victims in Bermuda. He had a co-conspirator sell these trunks of contaminated items near the White House, believing the material will kill them at 60 yards.
But it failed completely.
Because he didn't know the mosquito was the vector, not fomites-like clothing. And the ultimate historical irony is that Blackburn, who attempted this terror campaign, was later elected governor of Kentucky and promoted public health reforms. His tombstone says, "The Good Samaritan."
But biological warfare did succeed decades earlier, thanks to Napoleon at Walcheren in 1809.
Napoleon engineered a highly successful biological attack using malaria against a huge British invasion force. He knew about the summer fevers in the marshy Scheldt estuary. His genius was environmental manipulation. He intentionally breached the dikes.
Why was that so critical?
It flooded the entire area with brackish water, a mix of salt and fresh, creating the perfect, expansive mosquito breeding habitat just as the unseasoned British troops arrived.
The Walcheren fever was a devastating success.
A calculated disaster for the British. By the time they called it off, 40% of their 40,000-man force was impotent from malaria. 4,000 men dead, 13,000 incapacitated. A strategy later repeated by the Nazis in WWII.
Which brings us to the Pontine Marshes around Anzio, Italy in 1944.
The Nazis, desperate to stop the Allies, repeated Napoleon's strategy.
Wow.
They had drained the marshes, but they intentionally reflooded the area to create ideal breeding conditions and deployed malarious mosquitoes against the Allied front lines.
The only known purposeful deployment of a biological weapon in 20th century Europe.
Yes. Sergeant Rex Rainey, an American GI, was one of the soldiers who contracted malaria there. But his story gets even more chilling.
The second infection.
When his unit liberated Dachau, they found Nazi doctors had been doing heinous malaria research on prisoners. Rex was tragically infected with a second, worse dose of malaria from an experimental Nazi mosquito while securing the camp. It underscores how the mosquito is still a frontline weapon, even in modern conflict.
This era highlights the desperate need to understand the agent, which finally happened after the Spanish-American War in Cuba in 1898.
Right. When the U.S. landed, 75% of the Spanish force was already too sick to fight from yellow fever and malaria. The U.S. Army Yellow Fever Commission, led by Dr. Walter Reed, was deployed, and through meticulous experiments, they finally definitively unmasked the Aedes mosquito as the yellow fever vector, a revolutionary breakthrough.
And the practical application of this was immediately demonstrated by the construction of the Panama Canal.
Where the French had failed catastrophically, the Americans, armed with this new knowledge, succeeded spectacularly. Colonel William Gorgas, the chief sanitation officer, employed a sanitation blitzkrieg. His squad systematically eradicated yellow fever from the canal zone by 1906 and reduced malaria by 90%.
What were the practical steps?
Strict drainage of all stagnant water, constant fumigation, mandatory screens on all dwellings. They were so thorough, the sources note they consumed the entire U.S. supply of sulfur, pyrethrum, and kerosene oil in the effort.
And that success fundamentally changed the global power structure.
It secured American economic domination and naval supremacy. Canal building went from being a perilous enterprise to having a death rate half that of the U.S. It was proof that science could, for the first time, conquer the mosquito.
After the war, we entered the DDT era, which was hailed as the ultimate weapon.
And initially, it was a massive success. DDT and drugs like chloroquine led to the U.S. being declared malaria-free in 1951. Italy had 0 malaria deaths by 1948, ending Roman fever forever. Globally, between 1930 and 1970, these diseases were reduced by an astounding 90%.
Yeah.
It looked like we were winning.
But the mosquito fought back.
Resistance was not futile for the mosquito. Due to the massive use of the same chemical, insect populations quickly evolved genetic resistance to DDT. And then, combined with DDT's carcinogenic properties and the environmental scrutiny from Rachel Carson's Silent Spring, the World Health Organization officially gave up the eradication goal in 1969.
The sources are pretty blunt about human failings contributing to that.
Yes. Some experts at the time blamed resistant strains of Homo sapiens, meaning corrupt bureaucrats and critics who stopped the funding too early, allowing the mosquito to get the upper hand.
Meanwhile, a vital ancient discovery was resurfacing in Mao's China.
A remarkable story. During the Vietnam War, Mao's top-secret Project 523 was combing through ancient texts to solve the dire malaria rates in the North Vietnamese army. They rediscovered the anti-malarial properties of sweet wormwood, noted in that 2,200-year-old Chinese text.
And the chemist who isolated the compound was Tu Yu.
In 1971, She refined the compound, artemisinin, and by the late 70s, China reported a 97% reduction in malaria. Artemisinin is now the core of our best treatments. Artemisinin-based combination therapies, or ACTs.
But what's terrifying is that modern resistance is already failing this new drug, and the blame is being shifted back to human behavior.
A classic case of greed overriding global health. ACTs are combination therapies for a reason. The simultaneous assault by multiple drugs prevents the parasite from evolving resistance. However, drug companies realized they could make a quick profit by selling artemisinin alone because it was effective initially and cheaper to produce.
And the biological consequence of that.
Was creating massive selection pressure. The few parasites with slight natural resistance survived, reproduced, and created entirely resistant strains. This is why the sources upped the earlier condemnation to greedy strains of Homo sapiens, proving again that we are often our own worst enemy in this conflict.
And this predator is not content to stay put. Global warming, our increased mobility, the mosquito is expanding its range.
The warming planet is opening new fronts for this war. She's moving northward, southward, and into higher altitudes. And this brings us face to face with a modern scourge. Viruses we thought were contained are now threats everywhere.
Let's give the listener the scorecard on the new viruses.
West Nile debuted in the U.S. in 1999. It devastated wildlife, killing two-thirds of the crows in New York City. Then came Zika in 2015-2016. While rarely fatal to adults, it caused microcephaly in babies, a devastating birth defect. And crucially, Zika is transmissible sexually and vertically from mother to fetus.
And the great viral threat on the rise, dengue.
Dengue cases have increased 30-fold since 1960. We're talking 400 million infections a year. What makes it so dangerous is the risk of dengue hemorrhagic fever, which can be fatal, particularly on a second infection with a different strain. Given the expanding range of the Aedes mosquito, dengue is predicted to become endemic in places like Florida and Texas.
Which brings us to the ultimate question of the modern war. Can we, using our most advanced science, finally drive the mosquito to extinction?
We're talking about CRISPR, the revolutionary gene-altering technology that lets scientists snip out and replace sections of DNA. It's been dubbed the extinction drive, and it aims to defeat the mosquito by altering the rules of genetics itself.
The goal, championed by entities like the Gates Foundation, is the complete extermination of malaria. And the method is audacious.
Designer male mosquitoes are modified with dominant selfish genes, using a technology called a gene drive. These genes ensure they're passed down to almost 100% of their offspring, overriding the normal 50-50 rule. When released, these males breed with females to produce stillborn, infertile, or only male offspring.
And the theory is that the population just crashes.
The theory is the population would be extinct in 1 or 2 generations in a target zone. It's an immense research effort with over 3,500 human gene drive experiments underway.
This represents just immense power, the power to exterminate a species and, in the process, fundamentally remodel humankind's relationship with nature.
The sources note that the mosquito altered our DNA with sickle cell. Now we're seizing control of that process. The ability to cut and paste genes means, as one geneticist put it, everything is possible with CRISPR.
But the ethical stakes are massive. If we succeed, what are the unforeseen ecological consequences of removing a species that's a key part of the food chain for bats, fish, and other insects?
That is the essential debate, and it's happening right now in research labs worldwide. We are the product of millions of years of evolution, but now we can seize control of that process entirely. It's a biological risk, but one weighed against the persistent, staggering cost of 52 billion lives.
What stands out to me most is just the total insidious reach of this tiny predator. The mosquito sponsored the rise and fall of empires, from thinning the Persians at Marathon to crippling the Roman legions from within.
She gave birth to independent nations like Haiti and the United States, crippled entire economies like Scotland's, and slaughtered the greatest armies, whether they were led by Alexander, Napoleon, or Alaric.
General Xenophanes and Aedes were formidable weapons of war, consistently outmaneuvering the most celebrated commanders until modern science finally tipped the scales.
And even now, despite temporary setbacks from things like DDT, the mosquito remains the most hazardous animal to humankind, adapting her expanding range to a warming planet and ever-increasing global travel.
The mosquito altered our DNA in the form of sickle cell, an imperfect defense that cost many lives, but ultimately saved our species from extinction in the face of falciparum malaria. It was a brutal form of biological coevolution.
And now, with CRISPR, humanity can intentionally seize control of its own evolution and the fate of an entire species.
So, if we can apply genetic editing to eradicate our deadliest predator and end the suffering caused by malaria, dengue, and yellow fever, what does this new power mean for how we view ourselves and the future of genetic intervention?
If the mosquito forced us to evolve, and now we can force the mosquito to cease existing, what are the ultimate limits, if any, when humanity takes control of the blueprint for life and death?
That is the biggest question raised by this source material, and it is something for you to mull over in the days ahead. Thank you for joining us for this deep dive.